So good evening all of you. So today we will see some features of the drafting, and then we will go to geometrical dimensions and tolerances session. So in first half sessions we will see features, and in second half we will see GD&T. In last sessions we have studied how to create a views and how to assign the dimensions. Now we will see some basics. Okay, some basics features means how to assign center mark, center line, divisions, cloud. Okay, so these one. I will share my screen. Okay, I will go to drafting, click on OK. Okay, so I will go to A4 landscape. Okay, so in last we have completed this drawing tools. Now we will go to annotations. So in annotations, mostly we have know the symbols. Okay, so in smart dimensions, what we do, we assign the dimensions. Now, what is the model items? Okay, model item is nothing but it's a dimensions, but these are automatic. Okay, I will show you the exercise. For example, on this one, I will go to browse and click any part. Suppose I select a end plate. Okay, I select end plate. Okay, same. I will create one more. Okay, so I create a front view, top view of the end plate. For one top plate and in front view, top view, I will assign, go to annotation, and I will assign smart dimensions. So in smart dimensions, if I select this edge, okay, if I select this edge, so here you will get a dimension. Okay, I will convert it into millimeter. Okay, so by the smart dimensions, you can assign individual dimensions. But when I select a model item, okay, when I select a model item and select a view, okay, so here if you say, you will get a by default 4x4 dimensions. If I select again this whole, so here you will get this center line. So means from this point to this point, you will get by default center line 3:3. Okay, from this point to this point it's 3, and from this point to this point is 3. Even you will get a by default diameter also 0.26, and even you will get this circle center. Okay, circle center dimensions from this edge in horizontal it's 0.5, and in vertical from this edge to this center it's a 0.5. Okay, so this is the meaning. In smart dimensions, you can assign individual dimensions. Okay, in smart dimensions, sorry, in smart dimensions, you will get an individual dimension. In model item, if you select any entity, okay, so you will get a total dimensions. Means if I select this edge for this circle, okay, so if you see, you will get a diameter for this one and this one. Okay, we have not. But what you have to do here, you have to just align a proper dimension representation. Means if you see it's not easily visible from which to which, so just arrange 0.5 so that it will be very helpful for user to get a clear visibility. Okay, so this is the difference. Smart dimensions, you can assign individual dimensions, and in model item you can assign the, if I select this edge, so it's a, you will get a horizontal and vertical dimension. If you select this circle, so you will get a the position of the circle, it's a diameter 0.5, 0.26, and the center position from your origin. Okay, so it's a horizontal in 0.5 and in vertical 0.5. We have not assigned individual dimensions here. We have assigned only here. Okay, if I go to smart dimensions and if I select this circle, so here you will get only the diameter, but not a position. Means from origin, how much it's in X and how much is in Y. So this is the difference between smart dimensions and model item. In second, we have this node. Okay, why we require node? Suppose in most of the time, I want to assign part number, part name, or any text, part number, part name, or any text. Suppose I want to assign the part name here for this one. Okay, or I want to assign the chamfer, because here we don't have the feature to assign the chamfer by default. So I want to assign the part name or number. So suppose here I know it's a end plate. So I will assign end plate. Okay. Then most of the time you have seen in your sketch, you will get some text. Okay, you will get some text. What is my text? Most of the time you have seen such a, if I click on note and just mention here. Okay, so you have seen note dash all dimensions are in mm. Okay, such a note you have seen. So this is the requirement. Okay, for this one we required note. Second, in linear or in circular pattern, already we know. Suppose if I select a linear pattern, okay, I know it's a linear pattern, then you will get here direction 1, direction 2. Already we use in part modeling and in drafting also, right? त्यामुळे so select a node to pattern. Which node you want to pattern? So here I have, it's a end plate. Okay, I want in X and Y direction. Okay, so I select here how many text I require in 2. The distance between this point to this point, it's a 10. I want to reduce it 5. Then in Y, suppose I want 2. Okay, I want to reduce the dimensions. Okay, and if I click on OK, so then you will get here 4 end plate text. End plate text. Okay, so if you have the same part in X and Y dimensions, so that you can use this note. Okay, here you will not get a dimensions, it's a use for the note, this note. Okay, not for dimensions. Then the balloon. Balloon is used for to assigning the part number or the sequence. So in yesterday's session, we have seen if we have the assembly. Okay, I will delete again. Okay, and I will make it drafting. Okay, if I import the assembly, okay, so here what we have front view, top view, and isometric view. Now if I go to annotation and click on balloon, okay, I click on balloon. So here I will assign it's my first number, this one is second. Okay, so it represents it's a part number. If you want to edit it, just double click on it, or you can assign auto balloon. If I select auto balloon means, okay, if I select auto balloon and select this assembly, so the here you will get a how many parts, okay, how many parts I used in assembly. Okay, now I want to make it bill of material. Bill of material means it's a you will get a serial number, part name, description, and quantity. So you will get a go to table and go to bill of material. So go to bill of material and select your assembly. Okay, select assembly and click on OK. When you click on OK, you will get a such a list. In list, what you will get a item number, part number, description, and quantity. Okay, here you will get a one represents end plate, two represents disk, three represents support pin, like this. And this one is the part number. If I save this end plate as a part number 001, so the instead of end plate, so the here you will get a 001. Same for disk, but we save this part by using some names like end plate, disk, support pins. So that's why you will get here part number. In descriptions, you can assign manufacturing process or part description. Okay, like material. Okay, so just what you have to do, just double click on it. You will get a just click on keep link, and you can assign here material. Suppose I want to this part as a MS means mild steel. Okay, so such a descriptions I want to assign for end plate. How many end plates I use in assembly? So here you will get a 2. This one and this one. How many discs I use? 1. Support pin 4. Spacer 1. Bolt 4. Nut 4. So this is the quantity whatever you use in your assembly. So we call it as a bill of material. Bill of material is a very important feature when you will get an assembly. Okay, it's used for the main assembly. Okay, so please try to create a bill of material during your assembly, not in single part. Okay, then whole call out. Okay, whole call out. For this one, what I will do, I will okay, I will select edit and create a view. Okay, here I will select this one represents hidden lines with edges. Okay, now I don't want to assign the thickness here, but for this hole, I want to assign diameter plus depth. Okay, diameter with depth. So that go to annotation and select a hole callout. When you select a hole callout and just select a circle. Okay, so the what you will get here, you will get a diameter of this hole. It's a 0.26, and how much it's a depth? It's a through, means it's a throughout. Okay, diameter it's a how much? Diameter 0.96, and how much it's a depth? It's a throughout. I will select second example. Okay, if I select a bush, okay, so we select a bush. Now I want to assign the diameter with depth. So I will go to annotation, select on hole callout, select point, okay, or circle. So that you will get a depth. So here what we have. So for this circle, it's a diameter how much? 25 it's a diameter, and depth how much? It's a 60. If I measure now the distance or depth from this edge to this edge, it's a throughout. If I select this one view, this view, and click on the hidden lines visible, so the here you will, from this dotted line you will get idea. It's a throughout from this point to this point. If I measure from this to this, okay, so they see what you will get. You will get a depth. Okay, so this is the use of the hole callout. What you have to do, you have to just select a circle so that you will get a depth, right? Then, okay, so for these 3 and 5, we will see the session again. Now, the next thing is center mark. If we don't have the center mark like this one, okay, now I want to assign a center mark for this circle. So I'll go to center mark and just select a circle. Okay, so when you get a select a circle, you will get a center mark. So this is called as a center mark. You can increase or decrease also. Okay, so sometimes when you see such a representation, it's not clearly visible and understanding. Okay, so what you have to do, just delete this one. Okay, if I go to center mark and select a circle. Okay, so this is the use. Then center line. Where is the center line? So I want to represent the center line of this cylinder. Okay, so it's a cylinder. Okay, so we know it's a bush. So having the center line. So go to center line and select two edges. Okay, if I select this edge and this edge, okay, so you will get a here center line. Okay, I will click on undo. Okay, so now it's there is no any center line. So I will select a center line, assign point this edge and this edge. So between these two edges, he will create a center line. If I create center line for this and this, okay, for this one and this one, so what I'll do, go to center line and click on this point. Okay, so here you will get this center line. So these are some basics. In Word, you will get idea what you mean by center line. And if you hold the circle cursor on your feature, okay, so you will get a message insert a center mark on a circle edge, slot edge, or sketch entity. Okay, sketch entity. Center mark displays the center of the arc or circular edge. For ease of dimensioning or editing sketches, use the property manager to customize the center mark so that you can easily change the length, okay, whatever you require. Okay, then next thing is hatching. Okay, what is meant by hatching? Already we've seen the hatching in section view. Okay, why we require hatching? So I want to represent a material at a particular location, at a particular location, so that you will get a hatching portion. If I cut a part, if you see this example in section view, what you will get? If I cut this cylindrical portion, okay, if I cut this cylindrical portion, okay, if I select a section view and click on vertical, and if I cut the part from center line, okay, so what you'll get if I cut a part from center line, so here in middle portion we don't have material cut. Okay, we have not cut any material, we cut a material only this portion, so that's why you'll get a hatching here. Now same representation I want to assign without using section view, so I will go to annotation and select on area, hatch or fill. But what we have, we require a close profile. Okay, so here we have the lots of options. Okay, so this one represents plastic rubber. If I select a solid, you will get this solid or in black. None means you will not get any hatching portion. If I select hatching again and click on brick, okay, so they will get a such a I will reduce this view. Okay, so if you see this line, it's a 1. If I reduce the scale, okay, if I increase the entities, okay, so these are the entities. If you click on the 1, he will scale or he will assign the gap 1:1. If I reduce the gap by increasing scale, so they will get a these lines. So now you will get an idea. This lines represents hatching. So this is the use of the to represent a cut section or material representation. Okay. Then the next thing is revision cloud. Revision cloud it's a very simple in cloud shape. Okay. Here we have the shapes rectangular, it's a ellipse, irregular polygon, and freehand. When I click on the cloud shape and just assign the first point and second point, so that you will get a cloud in rectangular shape. If I go to cloud revision again, if I click on ellipse, so that you will get a elliptical shape. Same if I select on irregular, okay, so you will get a irregular shape. If I click on freehand, okay, just move your mouse and just click on end point, so that you will get a irregular shape. But in freehand, okay, you have to select a point. In irregular shape, sorry, in freehand, you don't have the option to select a point. Just move your mouse and click on end point again. So you will close your cloud profile. If I click on irregular polygon, okay, you have to select a point. In rectangle, you will get this rectangular shape, and in elliptical, you will get elliptical shape. So same, why we require this cloud feature? If I select on revision cloud, you will get a insert a shape in a drawing to clearly display the annotations, or you can use the same feature for highlighting any particular area. Okay, highlighting particular area. Suppose I want to highlight this portion without changing dimensions, or it's a what we call it, it's a without assigning detail view or crop view. So I want to assign, or I want to display only a particular area. So I will select a freehand and click on, okay, so that you will get a this cloud shape. Okay, so this is the function of these dimensions. Okay, so now we will go to GD&T. It's a very simple. In smart dimensions, we already studied how to assign dimensions in part modeling, in assembly. Okay, same what you have to do, just go to smart dimension and assign a dimension from, suppose I want to assign the diameter for this one. Okay, you cannot change the dimensions. If you change the dimensions in part, okay, if I go to again, or if I open the part, okay, if I click on the new, click on the part, or if I click on open and click on boost, okay, it's the same part. Now if I go to sketch, edit, okay, so here we get outer diameter, it's a 40. If I increase here 60, okay, if I increase here 60 and exit from sketch, so that you will get here outer diameter, it's a 60. If I go to again drawing, okay, go to Windows and select a end plate sheet, okay, and click on OK. So now if you see, you will get here a 60. Okay, so this is the, here you can assign only dimensions, you cannot change. Okay, if you change in part modeling, your sheet or drafting sheet will automatically update. Okay, now if I go to, okay, so these are the some representations. Now we will go to some theory of the GD&T. Where we use the GD&T? Okay, if I go to here in geometrical dimensions and intolerances. So here we have studied, or we have to study these symbols. Okay, what is the meaning of these symbols? What is meant by tolerance, inclearance, transition, interference fades. Then what is my primary, secondary, tertiary? Okay, and then we will see what is my M, L, S, T. Okay, so now we will go to one by one. So go to geometrical dimensions and tolerances. So here we have the almost 257 PPTs. Okay, so today we will not see this one. I will share this PPT with you. It's a complete theoretical theory or theoretical session, but it's a very important for assigning the dimensions and your tolerances. Okay, the history behind in GD&T is has developed a method, a question and measure to prove about the form, orientation and location. Okay, form, orientation and location. These are the some profiles. Okay, so these are the some profiles. We will see one by one profiles. In profiles, you will get a perpendicular, horizontal, symmetry, concentricity, circular runout, total runout. Okay, angularity. So these are the comes under this form, orientation and location. GD&T has uses spatial punctuation and grammar rules, and it's important to use them properly in order to prevent misinterpretation. So it takes a time, practice, patience to become a familiar with GD&T system. So in first attempt, you will not get a clear idea where we use this GD&T. But by using some practice and some, again, the knowledge, if you studying on regular basis, you will get a clear idea. Okay, so who developed this GD&T? So it's developed by René Descartes. Okay, so if you see this name, René Descartes, it's a French mathematician, philosopher, and scientist who developed this GD&T. Okay. Okay, so the background of GD&T is the American Society of Mechanical Engineering, an international organization for standardization work together to create a system for a part design that can be understood and used around the world. Okay, so in current market we use the ASME Y 14.5 M version and ISO 1101. Okay, it's a American Society. ASME means American Society of Mechanical Engineering, and it's a version in Y 14.5 M, and in Indian Standard Organization in you will get a 1101. Okay, so this book mostly in industry we use for GD&T purpose. I have this book, I will share with you. Okay, so don't worry, just read. Then GD&T. Okay, so if you see this representation, okay, so if you have this single plate and hole, so what we assign? So we assign only this 50.2 or 50 by 14. Okay, so we assign only this dimension. But practically or during manufacturing, we don't have the control on these dimensions. Why don't we have the controls? Because of during manufacturing, you will get some manufacturing defects during your materials. Okay, if you have the brittle material, and if you are machining, at some portion you can't control the movement. Okay, it depends on user also or manufacturer. If you are the skilled worker, Okay, so he can create a exact dimensions. But if you don't have the skilled worker, so he will create some error in manufacturing. So we considering these parameters. So that's why we maintain some tolerance. Okay, we maintain some tolerance. Here we have maintained, okay, if you see this 50.2 and 49.8, here we mention, if I mention 50, okay, so it's not possible to create exactly 50. You will get a 49.8 and 50.2. So we define this tolerance. So between, if my object is between these dimensions, so it's acceptable. If not, then I will reject it. Okay. Then here, if you see here, you will get A, B, and C. A, B, and C. ABC means these are the reference dimensions. Okay, we will see one by one. These are the reference dimensions. Here, if you see this M with circle, okay, M with circle, it represents maximum material condition. Okay, here we have the two concepts. M with circle, it represents maximum material condition, and L and circle, you will get a least material condition. Okay. Then only standards in the world to define your part geometries. In second, it is a tool to communicate better and create more robust products. Okay. So what is a GD&T? It is a standard set of symbols, rules, and vocabulary to clearly define the drawings. Okay. So in your during grammars, we have some rules. Same in GD&T, we have some rules. Okay, here we have some rules. Here we have to assign proper datum. Okay, if you see this ABC, these are the datums. Then some tolerances. Okay, some tolerances like 50.2 to 49.8. Then dimensions. You have to assign a particular location or easily understanding point. If you see this A, okay, and if I just drag and if I mention, if this line intersect with this line and the 2 or 3 dimensions are merging in each other, so it's not easily visible. Okay, so that's why your dimension representation is also important. Then what is the GD&T? Okay, so where we use the GD&T? So during production, design, and quality, we require GD&T. If you create any thread during design, your production and quality will deflect. If you measure and you are getting some error during quality, okay, so it means your production will also deflect. So these are some depends on each other. Okay, during initially part development or during your inspection also. Then the drawings drive the entire process. Okay, this is the starting to end. Provides the two-way communication between the department. Okay, if you see here we have the two department. One department represents engineering department and second one represents production. Okay, if you are getting difficulties in production, you can throw back it's your results or your observations into engineering. And if you during engineering, if you are getting some errors, okay, so that you can assign to production. Then clear design intent. Okay, if you see the distance, if you see this 35, okay, we have the same dimensions. If I measure 35 in upper and 35 in lower, it's not a clearly visibility or understanding. So for understanding purpose, we have to maintain a symmetry or in equal dimension or equal representations for understanding. So such a rules we have to maintain. Okay, so why we require GD&T? So shorter cycle time from concept to manufacturing. So originally for developing this model, we required 15 months. Okay, so by using GD&T, now we will get a 10 months for concepts, from concept to launch. So this is the advantages. You will get a 5 months advantage, so that you can easily launch your part within short time. Then less troubleshooting at startup. Okay, miss the market by 50%, and with GD&T to meet cost target with minimum troubleshooting at production startup. If you have not assigned the proper dimensions and tolerances to the part, it will increase your production time, even it will increase your cost also. Okay, and if you assign the proper GD&T, it will reduce your production cost, okay, or rework time. When should GD&T be used and why? Okay, so generally speaking, there are many instances that call for GD&T to be used. Some of the instances are when part features are critical to functions or interchangeability, when useful measuring techniques, when datum references are desirable, then when automation techniques in design and manufacturing required. So this is some theoretical, and initially you are just, it's a, hope so you have studied this in your second year or in first year. Okay, if not, I will share this PPT and book. Okay, so just go through it. Okay, these are the advantages: reduce scrap, high quality, less drawing changes, less fit and functional problem. In current standard ASME Y14.5, and we in India we use ISO. Okay, so GD&T, the definition of it's a standard set of symbols, rules, and vocabulary to clearly define the drawings. Okay, so it's a machining flow chart. Machining flow chart means where we require GD&T and where we stop it. So from design to completion means from start to end we require GD&T. So that's why it's a very important. If you are doing a job in production or in quality, you require GD&T. It's not necessary if you are working in design, okay, or in design department. GD&T is basic knowledge for each and every department. Okay, need of tolerance and dimensions. It's almost impossible to maintain strict degree of accuracy due to predictable inaccuracy of the manufacturing method. Okay, it's not possible to maintain exact dimensions during manufacturing. Then due to interchangeability and mass production. Okay, if you are using mass production, it's a very difficult to maintain same dimensions. It is impossible for operator to make a perfect setting. Okay, in machine, it's not possible to maintain perfect setting. Even if your worker is in first shift, a worker is used as a skilled worker, so that he will create a perfect part. But in B shift, we use a second worker, and he don't have the skill to create a same part, so that he will create some defects. So avoiding these defects, we maintain some tolerances. So here, what is meant by tolerance? It's a difference between maximum and minimum limits. Difference between maximum and minimum limit. If you see the example, okay, so the dimension is given as a 1.625 plus minus 0.00, sorry, 0.002. So it's a minimum, meaning it, so you can create a part, it's 1.627 or 1.623. If your part is between these two dimensions, it's acceptable. If you see this expressing tolerances, okay, here we have these 8 types of the representation. Equal bilateral tolerance. Okay, it's a 1 plus minus 0.05. Okay, so it's equal in above and below. Bilateral. In plus, I require 0.05, and in minus, I acceptable it's a 0.02. Unilateral plus tolerance. I don't want a minus. Okay, if I have the 100, I accept 1.05, 1.05, but not acceptable 99.05. Okay, I don't accept 99.05. I accept 1.05. Unilateral minus tolerance. I accept in minus, not in plus. Plus limit two tolerances. Okay, so I accept up to 1.05 to 1.98. Okay, so it's a same like bilateral tolerances, but the representation is different. Then limit one lines. Okay, so you'll get in same lines. If you see plus, limit two lines in top and bottom. Same dimensions you will get in horizontal. Specified tolerances for the assembly. Okay, so it's a interchangeability. Interchangeability means which can be substituted for the similar part manufacturing to the same drawing. This interchangeability allows easy assembly of new devices and easier repair of the existing device, while minimizing both the time and amount of skill required by the person during the assembly or repair. Means if I have the washer, okay, on during assembly, I use the first washer, you will get a perfect, it's a perfect use for nut and bolt. And if I use the second washer, okay, so what we required or it's acceptable is it will work as a first one. So to avoiding this interchangeability, okay, so we can use this interchange. I can use second, third, fourth, fifth one. Okay, I will get a same result. Additional approaches to dimensioning and tolerances. Okay, so these are the interchange. It depends on each other in product design, quality control, manufacturing. Tolerances versus manufacturing process. Okay, nominal tolerance for steel. If you see this graph, in X direction, you will get a tolerance. In Y directions, you will get a cost. If you go to higher tolerance, okay, if you go to higher tolerance, you will get a higher cost. If you use less tolerance, you will require less manufacturing cost. Okay, so tighter tolerance increase the cost. Okay, if you increase the tolerance, you will get a higher cost. Okay, then these are some IT grades. IT grades means international tolerance grade. Okay, IT grades means it's international tolerance grade. These tolerances grade are divided into these 5 types. Okay, from IT01 to IT06. This is used for tolerance for production of gauges and measuring instrument. IT05 to IT12 for fits in precision and general engineering. IT11 to IT16 for production of the semi-product. IT16 to IT18 for structures. IT11 to IT18 is used for specific limit deviations of non-tolerated dimensions. Then if you see this, in IT grade, you will get a manufacturing processes like boring, turning, swagging, milling, drilling, forging, sand casting. So this comes under in black portion, means tolerance comes under IT2 to 5. Honing comes under IT3 to 5. Then in in drilling, okay, so drilling comes under IT11 to IT14. So these are the grades. Then the limits. Okay, so these are the in bottom represents it's a hole and upper represents the shaft. Okay, so consider we have this bottom part represents nut and top part represents your bolt. Okay, bottom parts represents nut and top parts represents your bolt. Okay, so this is the zero line. Okay, zero lines, it's our required line, but due to some tolerances, we will get these deviations in upper deviation and lower deviation. If in bolt or in shaft, okay, in shaft, maximum size it's a bolt dimension and tolerance. If you require higher than this shaft, okay, so it's a upper deviation. If you see this gap, then lower deviation, if you will get a minimum shaft diameter and the tolerance lines, it's you will get a lower deviation. If you get here definitions of this nominal diameter, nominal size, basic size. Okay, hope so. It's a I'm considering it's a boring to all of you. Okay, so I will show you just okay, I will share this PPT with you. Okay, just go through it. Okay, just read it. During reading, due to some readings, you'll get an idea. Already you have studied this one. Now we will go to some tolerances profiles. Okay, so these are. So these are the types of tolerances. You will get a form, profile, orientation, location, and runout. These are the main 5 types of the tolerances. These types of the tolerances are divided into characteristics. Okay, so the form is divided into straightness, flatness, circularity, and cylindricity. So it's a you will get a symbols also. Straightness represents straight line, flatness represents diamond shape, circularity represents circle, cylinder represents circle with 2 lines. Okay, so the same for profile. In profile, you will get a profile of a line, profile of a surface. In orientation, you will get angularity, perpendicularity, parallelism. In location, you will get a position, concentricity, symmetry. And in runout, you will get a circular runout and total runout. Okay, then in most of the time you have seen these symbols. Okay, so if I go to SolidWorks, okay, so these symbols, the meaning of this symbol is here. M with circle represents maximum material condition. L represents least material condition. Okay, so this is the theory I already mentioned in above PPT. I just go through it. Even some images also there. Okay, then projected tolerance zone, free state, tangent plane, diameter, spherical diameter, R represents R radius, spherical radius, control radius, references, arc length, statistical tolerances, and between. So in above tangent plane, okay, above tangent plane and M, maximum material condition, these are the modified symbols, and it's a, and then below it's a additional symbol. Additional symbols, it's not a necessary. Okay, but we have to maintain this maximum material, least material, projected tolerance, free states, and tangent plane. Okay, so here, when you assign any dimensions to any part, okay, you will get this result. But what is the meaning of this result? So first block represents geometrical characteristics. First block represents geometrical characteristics. In second block, you will get 3 divisions. Okay, so in first you will get a shape of tolerance zone, second size of tolerance zone, and material condition. Okay, so in second. In third, what you will get? You will get a datum plus maximum material condition or least material condition. It depends on material condition modifier. In second, sorry, in fourth, you will get a secondary datum, and in last, you will get a tertiary datum. We required 3 datums for particular location definition. Okay, so these are the tolerances types. First represents parallel line. Okay, so in straight, in flat, in circular, in curvature. Okay, for cylindrical also. Then even for curvature between 2. Okay. Now we will see one by one. It's a straightness. Okay, so this one is straightness representation. It is the condition in which element of a surface, its axis are in straight line. It's a geometrical characteristic symbols for a straightness tolerance is horizontal line. If you have this cylinder and if you create a straight line, okay, so this line must comes under your between tolerance. Okay, so if you see in between in tolerance zone, if you create this straight line, which one? This straight line. Okay, so we maintain some tolerance. Here if you see, you will get a diameter 0.5 and in below you will get a 0.495. Okay, so here this is the tolerance line, or this is tolerance between, or the space between these two lines is how much? 0.002. So this line comes under between this tolerance. What is the meaning? This surface, okay, you will get in some portion in up and down, but not more than 0.002 tolerance. Okay, so how to inspect this one? So here you will get this pink color line or scale. If you placed on one point, and you will get and if you place on end point, starting point, end point, so in between you have to touch maximum points. Okay, you have to touch a maximum points. Okay, so then and then only you will get a straightness. Same for flatness. Okay, so flatness represents is a diagonal symbol. Flatness depends how much a surface can vary from its a perfect plane, of which the upper limit plane must contact the actual feature surface. Okay, so this flatness is mostly used for the flat surfaces. Okay, is used for the flat surfaces. The applications are gasket, mating parts, and better contact with datum plane. Okay, so same this flat surface. Okay, I will keep this it's a leveling feet on object, and on one end I will keep the gauge. Okay, and I will move this gauge on this flat surface or leveling feet. If the die will deflect, okay, so you will get a deflection in tolerance. If die will not deflect, so we consider it's a flat. Same for circularity. Circularity is a condition of cylindrical surface other than sphere at any cross section. Okay, so the same, what we will do, we will get a precision spindle. On spindle, what we will keep this part. Okay, this pink part we will keep. So we will keep one point on this part and one end is connected to the gauge. If this gauge will deflect, you will get a deflection on the part. If deflection is between our acceptable tolerances, here we have the tolerance, it's a 0.002. If this die deflect between 0.002, then it's a acceptable. If not, then we have to reject it. Okay, then cylindricity. Okay, so if you see here the image, okay, cylindricity, it's a perfect cylindricity. If you see this straight line, okay, if you see this straight line, you will get a cylindricity. But if you get some defects on this cylinder, okay, it's an up and down profile, so it's a not a acceptable. Okay, it's not acceptable. If you see this cross section, it's a perfect circle, and if you see this second image, you will get a error. Okay, so these are the comes under your form tolerances. Then orientation controls. Okay, so these are the perpendicularity. We have to keep our exact part on our flat surface. If you will get some tilted angle, okay, if you get some tilted angle or distance, if you see this, if you measure or create a center line from the center of the part, and if I create a point or straight line from another second point, if the gap between is more than 0.3, okay, if the gap is 0.3, then it's not acceptable. If the gap is between it's less than 0.2, then it's acceptable. Okay, so this is the use. Okay, say the same angularity. Okay, so if you see, if we have the existing this part, now we will assign the some tolerances. So what I will do, I will create a two lines. I will create a two lines. One represents above your profile and one represents below your profile. This tolerances or this surface is comes under this line. Okay, this irregular shape comes under you this tolerances, you will get a deflection. Sorry, it's a you will get a exact part. If not, then we will reject it. Okay, so by using such a methods, you can measure angularity. Okay, here we have assigned the complete details how to measure. Okay, so just read it. Okay, so during reading, I am considering it's a boring to all of you, so that's why I'm just giving just basic knowledge. Okay, in the parallelism. Okay, if you see, I create a hole on this in block. Okay, I create a hole in block. Now, if you see these dotted lines, okay, so these dotted lines we must require in parallel. If you are not getting any parallel, okay, so that you will get some errors. Errors means if I want to insert this rod into the cylinder, and if you are on one end, you will get some conical portion, so that this bolt or this cylindrical portion will not insert perfectly. Okay, so at the end you will get some intersection. Okay, this part will intersect with this one. If you have the proper tolerances, we will go easily from one end to another end. Okay, in location controls, we have concentricity. Okay, what is my concentricity? Both circles or are required in same center. Okay, if you see this one. Okay, so here if you have the center, okay, so both circles having same center. If this center is deflect from position, how much? 0.3. Okay, 0.3. Or if you see here the tolerance 0, it's a diameter, and this one represents it's a tolerance. How much tolerance zone here? 0.3 diameter. Okay, so if the center deflect from center 0.3, this circle center and this circle center, if the center deflect from 0.3 zone, okay, zone means I will create two lines. Okay, so between these two lines, if center lies, then it's acceptable. Okay, symmetry. Okay, we already know what is symmetry. From center line, okay, from center line, both lines were required in same dimensions. Okay, means from center line, if I have the 10 from the center to top, then in bottom we required center to bottom, it's a 10. Okay, so that you can measure like this one. Here we required the 2 gauges. Then positioner. Okay, if I have a single plate and I want to create a hole in center. Okay, so here we have the dimensions in X, it's a 1.889, and in Y, it's a 0.947. But some manufacturability, some skill, if you don't have, then it's acceptable. How much? It's a 0.01. Okay, means 1.89. 1.89. It's acceptable in X dimension. In Y, how much? It's a 0.95. 0.95, it's acceptable, but not more than. Okay, not more than. Okay, this is the summary. Okay, then run out. Okay, so most of the time you have seen the during your cycling, if your cycle front tire is not exactly in center, okay, so they you will get some wobble. Okay, or your control wheel or control on your cycle wheel, there is no any control easily. Okay, so why this one? So it's a run out, means this both circles, okay, both circles don't have the same center. Okay, so if you see here, if I want to measure the center, okay, from this diameter, so here we have the center. If you see these dotted two circles, so these two dotted circles represents our tolerance zone. If this circle surface comes under these dotted circles, then it's acceptable. If any one portion or one corner comes under internal circle or goes outer circle, then it's not acceptable. So it's called as a circular runout. It's a total runout. It's a from starting to end. Okay, so these are the profile control. Okay, so it's a profiles controls in profile of a surface and profile of a, here we have the two types. Profile of a surface and profile of a line. So these two types. If I have the inclined object, what I will do? I will create a tolerance zone for this inclined line. I will measure it by using gauge. If this gauge will deflect, you will get a tolerance. Okay, if the gauge will deflect within tolerance, so it's acceptable. If not, then it will create a difficulty. Then profile of a surface. Okay, so profile of surface, then profile of a line. Profile of surface is used for the mostly 2D, and this one is used for the 3D surfaces. Okay, so in X and Y, here we require the two datums. Here we require single datums, or three. If you see here we required in here three datums we have A, B, C, and in here we have the two datums. Two datums means three references or two references. I will take a dimensions in A and B from this to this surface. Okay, from these two dimensions, from these two references, I will measure the dimensions. So in surface, I will measure from three dimensions or three references. Okay, so this is the summary. Then in bottom, we have some how to assign the dimensions. Okay, how to assign dimensions. So this one also important. I will share this PPT. Okay, so just go through it. Okay, so now, so this is just an introduction of the GD&T. Okay, during exercises, some videos, I have some videos, PPT, books, I will share with you. Just go through it. Okay, just read it so that you will get a better idea. Okay, in one shot, it's a very difficult to understood these concepts. Okay, just go through one by one. Just read it, this PPT, videos, see some videos, read some books on GD&T. Okay, so and I'll give some exercises, how to assign dimensions, some what we call it, some exercises. Okay, so just you will get idea. Okay, so it's a very difficult to see in one shot. Okay, so I'll again repeat it. You have to take some efforts to read these PPTs, exercises, videos. Okay, so now this is the basic GD&T. So now we will stop this one. Okay, I know it's a you have more queries on GD&T. Okay, but before question answer session, I will request to just go through it. Okay, so that you will your most of the answers will get during your reading. Okay, so now today we will stop here, and tomorrow we will continue in